In this lesson, we will learn about prime numbers, the least common multiple, and the greatest common factor. A prime number is a natural number that has exactly two distinct natural number factors, 1 and itself. Two is the smallest prime number. It can only be divided evenly by the numbers 1 and 2. Two divided by 1 is 2. And 2 divided by 2 is 1. Since there are only two ways we can divide 2 without getting a decimal number, 2 is prime. The next prime number is 3. It can only be divided evenly by itself and 1. 3 over 1 equals 3. Three over 2 equals 1.5. And 3 over 3 equals 1. Since there are only two ways we can divide 3 without getting a decimal number, 3 is prime. The first 12 primes are listed. In part B, we are asked what a composite number is. A composite number is a natural number that has a positive factor other than 1 or itself. In other words, a composite number is any natural number greater than 1 that is not a prime number. The first composite number is 4, since it can be divided evenly by natural numbers other than 1 and 4. Four divided by 1 is 4. 4 divided by 2 is 2. Four divided by 3 is 1.3 repeating. And 4 divided by 4 is 1. Since there are more than two ways we can divide 4 without getting a decimal number, 4 is composite. The first 12 composite numbers are listed. In part C, we are asked why 0 and 1 are not considered to be prime numbers. Zero is not a prime number because it has infinite factors. Zero over 1 is 0. Zero over 2 is 0. Zero over 3 is 0. Zero can be divided by any non-zero number to get 0, so it is not prime. One is not a prime number because it has only one factor. A prime number needs two distinct factors. One divided by 1 is 1. This is the only way we can divide 1 without getting a decimal number. A prime number requires two ways, so 1 is not prime. Moving on to part D, what is prime factorization? Find the prime factorization of 12. Prime factorization is the process of breaking a composite number into its primes. We'll factor 12 by drawing out a factor tree. Four and 3 are factors of 12. 2 and 2 are factors of 4. The numbers 2, 2, and 3 are the prime factors of 12. Therefore, we can write 12 as a product of 2, 2, and 3. In part B, we are asked, what is the LCM? Find the LCM for 9 and 12 using two different methods. LCM is an acronym for least common multiple. It's often called lowest common multiple as well. Given two natural numbers, a and b, the LCM is the smallest number that is a multiple of both a and b. Now we'll find the LCM of 9 and 12. In method 1, we'll list multiples of each number and look for the lowest number that occurs in each list. List the first 6 multiples of 9. Now list the first 6 multiples of 12. "36 is the smallest number that occurs in both lists, so the LCM for 9 and 12 is 36. In method 2, we'll find the prime factors of each number. Collect the prime factors that occur most often for each number and multiply them together. Let's find the prime factors of 9 using a factor tree. Three and 3 are the factors of 9. Now we'll find the prime factors of 12 using a factor tree. 4 and 3 are the factors of 12. Two and 2 are the factors of 4. From the first factor tree, we can write 9 equals 3 times 3. From the second factor tree, we can write 12 equals 2 times 2 times 3. Now that we have the prime factorization of each number, we'll find the least common multiple. The number 2 occurs most often in the prime factorization of 12. Pull out both of the 2's. The number 3 occurs most often in the prime factorization of 9. Pull out both of the 3's. The product of these numbers is 36, so the least common multiple is 36. This is the same answer we got using method 1 earlier. In part F, we are asked, what is a GCF? Find the GCF for 16 and 24 using two different methods. GCF is an acronym for greatest common factor. Given two numbers, a and b, the GCF is the largest natural number that will divide both numbers without a remainder. Find the GCF of 16 and 24. In method 1, we'll list the factors of each number and find the largest number common to both lists. List all the factors of 16. Now list all of the factors of 24. Eight is the largest number that occurs in both lists. so the GCF of 16 and 24 is 8. In method 2, we'll find the prime factors of each number. Circle all common factors and multiply them together. Find the prime factors of 16 using a factor tree. Four and 4 are factors of 16. Each 4 breaks down to 2 times 2. Now we'll find the prime factors of 24 using a factor tree. Six and 4 are factors of 24. Six breaks down to 3 times 2, and 4 breaks down to 2 times 2. From the first factor tree, we can write 16 equals 2 times 2 times 2 times 2. From the second factor tree, we can write 24 equals 3 times 2 times 2 times 2. Now we'll find the GCF. Draw rectangles around factors that exist in both rows. Multiply 2, 2, and 2 together to get the GCF. The GCF is 8. This answers part F. Just to make sure you're clear on the concept, let's take a look at the numbers 4 and 6. The GCF for these numbers is 2. The GCF is the same as or less than the given numbers. The LCM for these numbers is 12. The LCM is the same as or greater than the given numbers.